Hello students, let us continue our discussion of the integrals which are of the form 1 upon a plus b sin x plus c cos x dx. Let us begin with an example. Here they have asked us to evaluate the integral 1 upon 5 plus 4 cos x dx. Now my dear students, this is an important question because this has been asked many times in the board exam. It does not have anything tricky but has been asked many times, so you should go through this question carefully and you should revise also. The very first step in the solution is known to us. Let us execute that. And we have seen the form. The form is 1 upon a plus b cos x. The method is tan of x by 2 is equal to t. So let us put tan of x by 2 is equal to t. So if tan of x by 2 is t, can I say x is equal to twice of tan inverse t? Very correct. We need to get the value of dx. We need to get the value of cos x in terms of t. So let us first find the value of dx in terms of dt. So differentiating with respect to x, we can say dx is equal to 2 upon 1 plus t square dt. Is that okay? I will require this value. We know the formula for cos x. Cos x is 1 minus tan square x by 2 upon 1 plus tan square x by 2, which is nothing but 1 minus t square upon 1 plus t square. My dear students, you are not supposed to write 1 minus tan square x by 2 upon 1 plus tan square x by 2 in the exam. It is not required. You may write. Now these are the values which I will require, and these values I have to substitute in the integral 1 upon 5 plus 4 cos x. So let me just substitute that. So the integral now will look like 2 upon 1 plus t square, and in the denominator I will have 5 plus 4 into 1 minus t square upon 1 plus t square dt. Next step is pretty obvious. We will take LCM. So the numerator will be 2. In the denominator I will have 5 into 1 plus t square plus 4 into 1 minus t square dt is there. So in the next step, can I write it as 2 upon? Now my dear students, if I open the brackets in the denominator, I get 5 plus 5t square plus 4 minus 4t square dt is there. Now 5t square minus 4t square, my dear students, is 9t square. Now before I write that, 2 in the numerator is a constant. Let me take that outside. So 2 times integral 1 upon, can I say 5t square minus 4t square as t square and 5 plus 4 as 9 dt. So can we write this? So in the next step, can I write this as 1 upon a tan inverse of x by a. So 2 into 1 by 3 tan inverse of x by 3 or t by 3 plus c. My dear students, the integral was of the form 1 upon x square plus a square. Now 2 by 3 tan inverse of t by 3, that is tan inverse of tan x by 2. So let us do that. So 2 by 3 tan inverse of tan x by 2 by 3 plus c. And that's a final answer. Let's take one sum for practice based on this same 1 upon 4 minus 5 cos x. Is that okay? Let's take one more example, my dear students. 1 upon 3 plus 2 sin x plus cos x dx. Let us copy the question. Now in this case, I will require the substitution. The substitution does not change. So let us write tan x by 2 is equal to t. So can we say x is twice of tan inverse t? And on differentiating, we will get dx is equal to 2 upon 1 plus t square dt. Now my dear students, in this case, I require the value of both sin x and cos x. So let us write sin x is, I will write directly as 2t upon 1 plus t square. Likewise, cos x I will write directly as 1 minus t square upon 1 plus t square. Is that okay, my dear students? Now these values I will have to give effect into this particular integral. So sin x, cos x I am keeping for your reference. The integral is also there. So let us make the changes. So the integral 1 upon, can I say 3 into or 3 plus 2 into 2t upon 1 plus t square plus 1 minus t square upon 1 plus t square and 2 dt upon 1 plus t square. Now the next step is taking LCM. So we will get integral of 1 plus t square upon 3 into 1 plus t square plus 2 into 2t, that is 4t plus 1 minus t square, and here I will write 2 dt upon 1 plus t square. Now my dear students, it's clear to us that 1 plus t square cancels. 2 is a constant, so we will write that as integral of 2 upon, let's open the brackets in the denominator. So we will get 3 plus 3t square plus 4t plus 1 minus t square, and dt is there. Now 3t square minus t square is 2t square plus 4t plus 4. So 2 times integral of, can I say 1 upon 2t square plus 4t plus 4 dt. Now my dear students, you can see 2 is a common, factor to the denominator. There is a 2 outside the integral. So I'll just write this step for a reference, and in the cloud let me show a working where I am saying 2 and 2 will get cancelled. So in the next step we'll write integral of 1 upon t square plus 2t plus 2 dt. Now my dear students, this is a simple expression to convert to perfect square. We know that this can be written as 1 upon t square plus 2t plus something. Now some number here will make it as a perfect square, that's half into 2 the whole square, that is 1. So we will write 2 as 1 plus 1. Is that okay? And obviously there is a dt. Now t square plus 2t plus 1 is nothing but t plus 1 the whole square, and that plus 1 can be written as 1 square. Is that okay? Now again the integral is of the form 1 upon x square plus a square. So 1 by a, so that's 1 by 1 tan inverse of t plus 1 upon 1 plus c. That is nothing but tan inverse of t was tan x by 2. So tan x by 2 plus 1 plus c. That's your final answer. Now again you need to practice little bit. So in this particular type you can practice these two sums. So we have seen 2 sums and we have another 3 for practice. That's all I have in this module for you students. Thank you very much.